Yeah, interesting. I know the DNA works well because everyone else is just kind of guessing check. I mean, that's what I experienced in lab, and what it seems like in the paper too is you drop cast it, you hope for the best, and sometimes you get super biases, sometimes you don't. Or like with the DNA, you actually have a much higher percentage to actually get it.
What's your matrix?
What
are you putting it in?
It's just a solvent. So we're trying to do just two main ways that I see people do it. They'll do what's called like a linear budget film or trough. So they'll have like water. It's just a fancy word. They'll have like a
Levi is still missing. Oh my god.
Good hide.
oh, nice.
Yeah. Not easy.
No, it's not. Okay, so water.
So it's like water, but then the nanoparticles are organic solvents, soluble in organics.
No.
So you put the organic layer on top.
Yeah.
And then they evaporate, and then they'll form a monolayer on top. So that's one way. Or the other way is to just drop a film on a slide and hope for the best by trying to change different solvents temperature.
What about like spin cast?
Yeah, you probably can. I haven't seen a whole lot of people do that just because it's really fast. You want to usually give them time to find their arrangement, or if you spin cast it,
Depending on, that could get very expensive.
spin casting?
No, because you have a raw material that's wasted.
Yeah.
And it's silver.
Yeah, silver is actually pretty easy to make, surprisingly.
It's time to.
I'm saying silver metal is expensive.
Yeah.
I changed
15-20 minutes late.
I forget the full name, but it's PTC.
There's only 6 of us in here.
No, it's like full
Yeah, Brandon
phenol
always works, so he can't make it.
diethylcarbonate mate or something like that. So it's
The other undergrad,
Whitney's?
yeah, she usually shows.
carbon double
She's undergrad, isn't she?
sulfur, and then it's
She usually
connected
shows
to
up a little later too.
nitrogen, and then it's connected to a 3,5 phenol.
Okay.
Yeah.
So that is a lot of the PTC compounds coupled very well with the bond dot, so it effectively increases the volume or the size, so it shifts it.
Do you have like electron travel within the ligand?
Yeah, so like the HOMO and LUMO are delocalized into the ligand.
Ah, sweet.
But the problem is the ligand itself is unstable in different solvents.
That it will decompose?
Yes. Into carbon disulfide and then the rest of it. But once it gets on the point that is stable, but getting it on, you put in methanol, and that makes the decomposition 3 times faster, and you do that several times, so it's kind of so we're trying to demonstrate that you can't just think of it as a simple process going from native to the new ligands, because it might be some ligand that goes on that isn't there, that you think, like the nitrogen. Cadmium. So then that would be the problem. With that one, we're going to do non-adiabatic dynamics for this pretty much the same type of linkage. So on C, and then I forget the name of the
Yeah, you still connect.
acceptor, because that can make whole transfer go from nanosecond.
Are we waiting for anyone else, or it is enough?
to femtosecond?
Enough waiting.
Enough waiting.
Which is about electron.
You wanna go home sometime tonight?
We will be kicked out by 7.
Devices much.
I would be happy to stay here until 9, but no one cares. The active psychologists come and start their
You're saying the whole
activity.
speed goes fast as the electron.
Yeah.
So then it goes
Yeah, and then your device wouldn't get a positive.
So what are we doing today?
We are
Making
gonna
MOs.
plot some MOs.
What?
Plot MOs?
I can see.
Molecular orbitals.
A hidden person from the angle of the room tells that we are doing molecular orbitals. Oh. Why are we doing that?
To gain further insight.
That's too general. Everything we do is okay for insight.
Define the localization of electrons.
Good. So, we are coming here in order to do what? To get practical skills in characterizing materials computationally. And right now you all have successfully completed the homework on getting geometry and total energy. I've noticed some inconsistency in the theoretical question about spin. But with energies and geometries, everything was fine. It's not too rich to have only geometries and energies. We need to dig deeper. For example, several of you know how to turn knobs by real world instruments. And some of those instruments are spectrophotometers, where you dip your sample in a beaker, dip the beaker or whatever cuvette into the spectrophotometer, click the button, and then on the screen you have the spectrum, which measures the ability of a molecule to absorb or emit light. And this depends on the availability of electronic states with and without electrons in resonance with frequency of light. This goes along with your common knowledge. On the other hand, when we were in the class, we were talking about molecular orbitals, which are bridge between atomic orbitals and wave function. They are not originally the observables, but they in part reflect properties of materials, specifically the ability of a material to absorb light at a given frequency. The molecular orbitals and their specific energies are being computed while you are running Hadron-Fock calculation. They are recorded somewhere. And we have a, so to say, triple task for today. So first we look into .log file and identify where are the energies of orbitals. So from this first exercise that can be completely done in text mode without any graphical application, one can find the orbitals that are occupied, find orbitals that are unoccupied, and identify the energy difference between them, which can be recorded for any material, for any of the calculations that you have already completed. So, and it will be not a big secret if I tell that assignment in the next homework will be go across your samples and find energy gap between occupied and highest occupied and lowest unoccupied and plot them on the same panel for all models, seeing the trends for comparison. So it will be task 1. Task 2. If we have so many occupied and so many unoccupied, one needs a way to visualize hundreds of orbitals. Not orbitals, but energies of orbitals. Visualize energies of orbitals. Visualize energies of orbitals. So it will be so-called density of states. And the third thing would be to look for spatial distribution of this wave function amplitude corresponding to molecular orbitals in space. Plots, isosurfaces, electronic clouds. So we'll go through this 1, 2, 3 points, and then as the little entertainment during the weekend, you try to practice it to all of the models that you already have by now. If you will look into your emails, or if you will look on this little printout, there is a little menu. Enough? On what we are going to do. So let's log into the supercomputer cluster and select the simplest model, or one of the models that we are dealing with. So something. So we are going to the directory where we have a model with successfully completed Hartree-Fock calculation. It doesn't matter which one, but I just suggest to do for titanium hydroxide. It's small, condensed, and it has a little flavor of inorganic. So let's look through the .log file. So we do more, go through the file, and click space to go through it. So you see a lot of supplemental information that right now we are not needing, and then closer to the end of the file, you will see records that look about this way. So it will show alpha OCC eigenvalues, alpha Virch eigenvalues. Please let me know if you do not see it in your directory. Everyone does? So if you look on these numbers, you see that they are arranged in the ascending, growing order, from smaller to higher. So those are molecular orbitals occupied by electrons, and when we have sufficient number of orbitals to provide housing for all electrons, we start listing unoccupied, empty orbitals. So we do see two numbers, which are minus 0.5 something and minus, let me minus 0.5 something and then minus 0.012. Do you have similar numbers in your directory? Yeah, they can be a little different because of different optimization or different sober human error. What are these numbers? What are their units? Yes. And how to convert them into something pleasant? Huh?
Times by about 27.2.
So it means that for you, EV is mostly pleasant. What else pleasant can be? Like kilocalories per mole?
Kilojoules per mole.
Kilojoules per mole. Or maybe inverse centimeters?
Yeah.
Well, not for absolute values, but for difference between them. So what we are doing with these numbers, we are subtracting them and maybe converting to electron volt. We will do it just once because it is the silliest possible exercise. And we have powerful computers in front of us. We shouldn't do it frequently. So BC for board calculator, and then we do minus 0.012 minus 0.5. So it is about half of the atomic unit. And what it will be in the electron volts? So about
13.2 or 13.6 is exactly half.
So 13 something. Well, if you would believe this calculation, it will mean that titanium hydroxide doesn't absorb neither visible nor UV light, which is not too wrong. It appears as a white powder, colorless. But this 13 electron gap is somewhat exaggeration, because Hartree-Fock is not the best possible theory in the world. So it gives some qualitatively reasonable but quantitatively not perfect results. But it is what it is. We have theory that we more or less understand or starting to understand, and we have results provided by this instrument. So 13.3 V is the gap of this model. And then we can do the same for each of the models that we have at our availability. So we are done with number one. Yes?
I lost myself. I think the command is not working. I'm not sure.
So I will approach Faisal, and while it is going on, you can maybe find a couple of these band gaps and record it for other models towards the future homework.
So homo, so occupied or homos,
Stop
No,
together
I still
and
get
then
occupies the homo.
virtual.
Right now you
or-
don't need minus x. Well, later
So
you,
if we look
if
at
it is,
this here, it starts out very low in energy and it grows and it grows. So this is your homo, and this is your lumo.
So this is just a straight list of each.
Yeah, so it's just a matrix kind of. Like each row vector, if you transpose it into a common vector, and you put them on top of each other, it's just, this would be state 1, 2, 3, 4, 5, blah, 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 so,
okay,
so this is 25, 24, so this would be state 24. 25, 26, 7, 5.
Okay.
Which you can make a code to use like which I have.
and then just
Really.
You're a little bit more clever when it comes to
So I
new
need to,
pages than I am.
yes please, oh yeah.
It's not that big of a code. You want to see?
So till
Yeah,
100%?
I'll look at it, but I'm still gonna say you're killing me.
well, just point to you see.
Oh.
So it is
So each one of those is a
closer to the info.
What is that?
So you
So
look
it's
for
it reps this one.
that's my
What's good stand for?
you can do it different ways.
So
What
what
does
should I
it
look
stand for? What does it do?
There are many lines.
The ladder looks fast.
What does it do? It looks for a string
You should
in the file
for the
and it pulls
last
it out.
one.
So
the line
What?
Control F.
Alpha, oh, wait.
minus
Yeah.
0.5 something, and then you need
So if I
the
do
first
grab
one
So
Alpha
it's
in the
matrix.
virtual.
everything.
Oh.
alpha,
These two numbers, okay?
the quotations.
Huh?
This is very important because it's gonna grab anything
Alpha 5, the
verbatim,
last one, and the
this
first one of alpha virtual.
out
Then-
of
Make sense?
Okay.
this file. So it grabs everything with alpha space,
And
whatever.
alpha virtual. The
right?
last
And
one of
file
alpha
name.
but the first
Yeah,
one.
so in any text file. So let's say I only want virtual orbitals, you can put grep alpha space v, and now we'll only grep that.
Okay.
So like you could think,
So,
oh,
it was the, maybe we all understand it naturally, but better to verbalize it once again. So you are looking for the line that has a words alpha occupied eigenvalues and look for the last record in this line.
Last.
Last record for occupied. So it will be highest occupied. HO. And then you are looking into next line, which is alpha virtual eigenvalues, and look for the first one in this line,
Okay.
which will be LUMO, lowest unoccupied, LU. And then you subtract these two numbers and convert them by multiplying by 27.12 for conversion into electron volts.
so if you wanted to like
So it's
club
Lumo
these
minus Homo?
two lines, you could
Mhm.
just grab
LUMO minus HOMO, the highest minus lowest.
then that would only show you this guy, right? Then you can say tail to look at the end, tail minus 1, and it would only give you this line. And then you could do the same for this, for virtual, but it says tail, you say head minus 1, and that would only give you this line.
So it'd be grep alpha close.
Lumo minus Lumo numbers.
Tail, and tail gives you the end. So tail minus 1 gives you the last line.
Just like that.
Yeah, so there's a space.
in between the minus.
Yeah. So tail space
Yeah,
minus
it's
one.
minus
Okay.
0.01
And then
and
to-
0.
It's pretty much everything the same, but you change occupied virtual and then you say head.
And you need to take the
And it
last
will-
one
Yeah,
for that,
last
and for the first one for that.
Okay.
And
Everyone done with this little exercise? Any help needed? No? Okay. So let's consider the situation when we do have energies and we do have orbitals, some of which are occupied and some of which are unoccupied. If those are just few, then we are in a good standing and we can go as we did right now. But what if we, instead of 2, 3 orbitals, we have 10, 20, 100 or 1000? And what if the processes that we are interested are contributed by more than 2 orbitals? Because it could be absorption at higher excitation, and then we need more orbitals. How do we characterize so many orbitals altogether in general? We can draw a picture like this, but if there are so many that they overlay with each other, so it will be right. It will be very many here, very many there, but in one place it will be a little more than in another. So we can introduce the concept which is called how?
density of state. States. Sorry.
Yeah. Good, thank you. So we can count how many orbitals are provided per small window of energies. So we split all energy range onto small windows and then count. There are 0 here, 0 here, 0 here, so many here, a little bit less there, so many here. So we count number of orbitals, and then it will create approximate, well, not approximate, it will create average visual representation of many orbitals. And you can quickly look on them and recognize signatures of specific systems, of specific models. So it is in very primitive way structure to property relation. So density of states is the signature of a material. And for real life, for experiment, density of states can be directly measured by the scanning tunneling microscopy apparatus. So you put your piece of material, your molecule that you want to probe onto substrate, bring in a tip, connect them to bias voltage and measure the current while you're changing value of voltage. So if the valence band of the metal tip will match the energies of the energy levels of the material, then current will be higher. If they are in a mismatch, current will be lower. The actual situation is a little more complicated, but the idea is here. By turning knobs, or it is all computerized, of this voltage, scanning different voltage, energy levels of material come to matching or mismatching with the energy levels of the tip, and then current is higher or lower. And thus one can directly measure density of states. although it is not the best popular technique. There is one apparatus in 70 miles from here at UND Physics. So if you make friendship with them and send them samples, they can measure it. What are we doing? We do want to make this density of states for our models. So if you flip over, we want to generate pictures like this. So to show that at specific value of energy there are more states, at specific energy of states there are less or no states at all. And such images are good signatures of any material. How do we do it? So basically we can extract these numbers, convert them all into our favorite system of units like electron volts or kilocalories per mole, and then split your energy range onto small bins and count how many energies per this bin. It's one opportunity. Another one is it will be much more talking than actual doing. To do it is like 30 seconds and then we will be done. So right now I'm flipping over the energy axis as a horizontal, and then we have like energy of highest occupied, energy of lowest unoccupied, and there are more other energies. So we can do an artificial trick and consider that if we do have an energy of given value, then we will attribute a little non-zero profile, Gaussian or Lorentzian function to each of those. And then if you have several energies of several orbitals, then their profiles will add together and create higher peak or broader peak. So basically we add together contributions from each energy. And ideally, mathematically rigorously, it should be delta functions with infinitely small width. But practically we do something fatter than delta function. So here is density of states. If you have nothing to do, which I doubt, we can sit and write the code that will encode this equation and plot this function. But it is relatively popular and trivial tasks that all codes exist, right? So we are going to operate little scripts that parse Gaussian output file, extract the values of energies, and, so to say, wrap them up with these Gaussian profiles, and then generate figures. Objections? You like this plan? Good. So I was dealing with these scripts, but in case I doubt my memory, in case it will stop serving me well, I'm making little notes, and they are saved on the cluster. So if you look into the file advice.dos, bring it to bigger PC. So it is in the /binary subdirectory advice.dos something. There is a name of the script that converts the output of the Gaussian calculation into the list of energies and then into the image. I'm going to do this exercise for this little model, and then we'll invite you to follow me and do the same for your models. Okay. So I'm copying the script name here, and then here I am giving the name of the output file from the Gaussian that always ends with .log extension. And then I'm giving several arguments which answer the following questions. So there are 4 numbers arguments. First one, which has a value 1000 here, is how many grid points will be on the energy axis. The second one will be what will be the increment of energy for each grid point. And then the last 2 will be where to start and where to end the scanning of the density of states. What's the width of the window? So upon we do it once again. So here Perl, name of script, name of the Gaussian output file, and then 4 numbers separated by empty space. 1000 empty space, 0.1 empty space, 5 empty space, 5, and then hit enter. So let's see. Are there any files? Are there any new files generated in the directory? So we do have 4 new files. EOC, E virtual, E underscore, and then the repetition of the old name of the output file, and then DOS underscore, and then also some code information. So we may inspect each of these files and see what do they provide. So I'm typing more EOC. Please attract my attention if I'm too quick and I need to make a circle if you need to discuss any of the intermediate steps.
For some reason, the script isn't working for me.
That's easier to find.
Let me approach and see what happens. Yeah, I think I just.
It's Perl.
Did you get that? I didn't write. I think I typed it wrong.
Oh, the slash.
Slash, yes.
Yep.
The slash. Right there.
Ah, syntax.
So should we type like that
Mm-hmm.
and then
Okay.
okay. Okay, start. Just go to the file. This one. Go to your TL. Okay.
Okay, so if this step is completed, you can look onto the files, to this E sub OC. It does show list of all energies of occupied orbitals. So it's just parsing from the script. If you do E underscore virtual, it's just parsing on all unoccupied energies of unoccupied orbitals. So it's just simplifies life if we forgotten and never used much of Linux commands. And then if we look through the
Yeah.
file E underscore
Yeah.
and then the name of the output file,
Okay.
we see that it contains the same information just in the form of the colon instead of row. So the first line is number of orbitals, second line is energy of orbital in electron volts, third line is energy of orbital in atomic units, and the fourth line is number of electrons that are sitting on this orbital. So since it is a singlet, it's not a magnetic material, it's just 2 electrons on each of occupied orbitals, since it is closed shell.
Would you say that again? What were the rows, the columns?
Uh-huh.
E occupied, E virtual, and then what did you try?
Number of orbital, energy of orbital in electron volts, energy of orbital in atomic units, and number of electrons on given orbital. So number of electrons, which is for closed shell models, it is either 2 or 0. If it will be open shell, it could be like 1 and 0. And if it is metals, it could be like 0.1, 0.2, 0.3, because there is a probability of electron being here or there when the gap is approaching, when the gap is missing. Huh?
It could be 6, up to 6.
Just
Not
for,
aggregator molecule.
just for those transitions that you get into. F1.
In case of emergency, number of electrons per orbital can reach up to 6.
Yes.
No, with fixed quantum numbers, it cannot be more than 1, but here we do not care about spin, therefore there are 2.
So if there's degenerate orbitals, they show up, sends the same energy, and they
Yes.
keep putting 2 in there?
Right.
Okay. Alright.
There will be a list of like energy, orbital with energy -1, orbital like orbital number 10 with energy -1, orbital number 11 with energy -1, orbital number 12 with energy -1. And when you do density of states, then you will have just one peak, but with much higher height.
Well, what if the symmetry is broken and it's not exactly the same energy? It's like-
Then your peak in the density of states will be resolved. It will start splitting. Or if the splitting is very small, then the peak will be just broader. So we do have, by the way, if you do Control L, then it will clean your screen so that it doesn't have the garbage. LS minus LT. And we have the only one file missing from our attention that starts with D or S and then something.
I don't know why.
So you see, it is ugly list, ugly 4 columns.
Yeah.
What are they? What is our guess?
Well, it looks like it's the 10,000 or the 1,000.
It looks like the
Steps that
density
we
of
wanted.
state.
Yes, exactly. So it is value of the energy at the grid point, and then the value of the density of states for the given grid point. So those are those 1,000 points, and then heights of the density of states at each of these points that we want to plot as a continuous line. And there are 2 values of energies and 2 values of height of the density of states, because one of them is normalized for height, and 2 values of energy because one of them is shifted in respect to energy of the highest occupied. So to make a 0 exactly in between occupied and unoccupied. Okay, so if your origin as a computer program, or your Microsoft Excel are your favorite tools, you just download this file to your local computer and plot them with your software. So you do SCP for downloading, or you can practice it here. You can look on this panel.
I got disconnected right now.
This panel shows your okay.
Maybe.
Well, we will practice it as a next section. One day we will need it anyway. So, okay, here it is. So on the left panel there is a browsable list of directories, and I can go into my subdirectory based on the name and select the subdirectory where I'm working right now, titanium or 4H4. And here I see these files. So if I click on this DOS, it comes up to the screen, and I can just funnel it into Excel or Origin and put it. But what if I hate Origin? Oh no, if I hate Excel and I do not have money for Origin.
You use you use
Pirate.
Python.
Huh?
Said you pirate.
You use Python and Matplotlib.
Yeah, you use free shareware from Linux. Like anything included in Linux is free, and there are codes that replace anything that is available in Microsoft for free. It works a little worse, but it works. At the time when there were no Microsoft Windows at all, and when the graphical applications were very limited, I'm talking about like 1980s, people still wanted to do plots. And they did some very simple programs that are still available and work. So one of these codes is so-called GNU plot. So if you...
We can't see it.
You can see me. You cannot see what I'm drawing on the board. But if you look into Wikipedia, you will probably see some fun picture of a little deer or antelope, some animal for GNU. But typically, it is a segment of free software that starts with these 3 letters. And GNUplot is a code to make scientific images, but they are requested from the command line or the script, so without mouse. If we look onto several lines on the top of second page, we will see a little prompt how to do it. So since we wanted this code to be, we want a universal script that will work always, we may want to rename our file into generic name. So let's rename it just to dos.log. So I am clicking onto this command line and typing cp for copying, then this long ugly name, and calling dos.log. And I'm checking ls-lt head to see any new files generated here. Yes, dos.log. And if I will look I will see that it will contain the same ugly data as in the previous one. Now, let me look once again into this little menu. So it prompts that we need to run the GNUplot code with the script as an argument. Since we are curious scientists, we can look what is inside. So it is very simple command that we can type every day again and again. So it's just 4 lines, but why don't we repeat them again in the script? So it is basically plotting file dos.log using first and second line with a smooth line. So the last line of the script does matter. And here it sets up the output file where this graphical information will be tunneled to. So, yes?
Yeah, you can complete, then you have to come.
Yes. So, this is only for our curiosity in education. Practically, we need just to copy this line, GNUplot, empty space, tilde binary GNU proc _ dos-gauss, and click enter. That's it. No, you have already completed the step.
Wait, it's not.
Can you look at it?
It's coming to the
Jeez, you want Americanized?
No, I'm just dyslexic. Really, I'm dyslexic. Oh, I did. Kept running.
Oh, it's already here. If everything was working for you perfectly, inspect which files do you have, which new files you have in your directory. One? Yep. So you have good.
Be impressed if you could. So I'd be impressed if you could,
Okay.
restrict. Still not know how this works. Well, I just wanted to think about it.
I have got a little thing. So I'm copying this file into generic name.
Still have a solid hour of reactions.
Okay, so you need to get the file name DOS09.ps.
So that's my target file.
Yes,
So what does that file say?
I will explain it to you.
Oh,
Why?
I got lost.
That was tough.
Okay, so you do ls minus lt and inspect, do you have any new files generated?
Yes.
You do see DOS underscore G09PS.
Yep.
What does it mean? Any of you were active in 1980s?
Didn't exist.
I was active as in I was born.
Okay, okay.
Oh.
Let's ask Levi.
What?
What is .ps?
Dot PS? No idea.
Where-
Should I?
Yes.
I've never used that extension.
Who told this?
PostScript?
Yes, yes.
Yeah.
So it is the ancient format for saving graphical information, and it is the predecessor of the today's PDF.
It should be.
This file can be opened as a text file, and you can look through it. Like if I do more of this file, you see that it shows something reasonable. So it show line, width, and if you scroll through, it will tell like make little graphical object at this coordinate, so something reasonable and standardized. But we do not practice PostScript too much. We use PDF. Why don't we type PS to PDF, right? And then type the name of the file. DOS underscore something.ps. And now we check once again ls minus lt.
So this is sigma. So this is your Gaussian width. Then 5 is from each of the band up down. And so now we have
So how many extensions can you do that for?
This things.
Hmm?
Yes,
So,
I just typed
Is this just a generic way to do
Yeah.
any
no.
extension
So
version?
There are generic converters, and
Yeah.
you can or you cannot
Needs to change.
install them on your computer,
File.
or you can
yeah.
pay your administrator or
can be left the same.
threaten him that you will
Yeah.
stop paying him if he or she will not install them on the computer.
Did you say stock?
Stop? No. Stop.
Oh, I heard stock.
No, 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 no.
I was like, sometimes I do that, but I do it via email. Like, do this, please.
Well, that's not really stuff, dude. That's, yeah.
So you do ASCII?
No, you shouldn't do it. But there is you can Google for image converters
Well, yeah.
or image magic.
I was just curious to see how many can
Wait, so
There are some useful things for generating movies that we will go through in about a month.
Okay.
So now you have these files, and the EO, that's occupied, virtual, I actually never look at these files, I just look at the docs. So I believe that the docs, W period one, whatever, that's the file that we want to look at.
I wanna go back.
So if we do, like, I would do cat. And then just the name of the docs. Yeah, okay. So now it gives all the density of states and whatever.
So this is just the XY coordinates.
This, I guess,
I mean,
yeah,
this is the beginning.
yes, without it being plotted.
Right.
But
So it's more,
then,
isn't
if we look at,
So if I did a SC.
No, it's October
this,
something.
I could download this file.
you would have to do it from your computer.
October 13th.
So you
So
pull
the
it.
new file.
It's like 2 weeks away.
From here, and then I'd have it, so that's where I could put it in Excel. Yeah, SAP it.
You really don't.
Just be for my benefit, because I am pretty good with Excel.
But this script here does it automatically.
Awesome. This is
But
This
I guess
one,
this PS2 PDF RD changes it when
do
I
all these plots, or
just this GNU
Advice
new
on scheme?
pod,
So after you're done,
so that plots it.
what?
But like here you, so this GNU pod is, it will only plot DOS here.
Well, yeah, I understand that.
Right, so you take whatever this
he's
file
renaming this
is,
file.
yeah, so you rename, you're copying this file to a new file, then you're running this and then you're plotting it.
And then this, okay.
So then this PS2 whatever, this converts it to
So this is what actually makes it a plot.
Dimitri, why don't you just save it as a PNG directly from the GNU source?
After you, no,
So then,
I'll show you. You do not need that. Can you explain this TOP trick to Faisal? And explain why it is needed.
So you just go TOP, enter, and it just pulls
I'll
up.
approach this.
It basically pulls
so
up
then just copy what we just.
like the task manager for the, and it keeps you from being locked
What is
out.
going on?
I'm helping him go through the steps, he got lost.
What are we now?
We got the data, we got some stuff here, some density of states.
Can
Are we stopped? Did you hear what
Oh.
Seth told to
Oh.
Faisal?
Top.
Yes.
No, top is
So if I have
If you type TOP,
that
it will start the task analog of task manager, but it will block connection from coding.
I think
And I get out this by.
if it's benzene by itself,
By itself,
So
those electrons are
Get out from
two.
that command.
So you can only move the electron drawing if.
Just TOP. TOP.
To get
So-
out.
They say
so
Q.
by itself is
Yeah, so-
electromagnetic.
Looks like this. It's a task manager, right?
So what should I type?
What's
So
the
top.
T-stand?
TOP.
What's the T-stand?
long format arranged according to
You
the
can't,
Yep.
just list it under.
long
And it looks like
With
it's kind of like task manager, right?
times.
And this basically just keeps it
I'm so confused.
going, or keeps the supercomputer thinking that you're putting something into it.
Usually everybody
So
understands.
basically, you just watch like task manager go. But then it doesn't kick you out every
No.
2 minutes or 5
If
minutes
you
or
do
whatever it
again
is.
and again,
And then get out of
different
this
directories,
queue.
you will get different names.
We can
So let's say if I have
Yeah, you stay logged into the server.
Okay, so by typing on a stop.
Just top.
every 2 or 5 minutes later.
No, you don't have to type anything. You can. This has been sitting here for 10 minutes.
Oh,
That's good, thanks.
Instead of going through all of it.
all the steps again and again. That's really helpful. Yeah, especially for you.
Benzene, electron withdrawal.
Now I have done this thing.
It depends on.
Yep. That was exactly my point.
Yeah.
Oh, so you're saying that the benzene, if it's considered with something else,
Well,
if it's.
Yeah, I can understand.
And
It's
after
Yeah,
that,
I
I still
don't
need
choose.
to type in that.
so that would be an electron withdrawal.
that one. LS.
Why?
So if you have R here, your R group is gonna donate some electron density because this is a very electron withdrawing group.
Oh, with.
drop resonance form.
Yes.
Going to end up getting double bond. So this is
Right.
So if you just have a benzene, it's kind of neutral.
Yeah, that's what I
So it's going on.
Though more when you actually do substitution reactions.
No, it's just
This is
going
the
on.
post script, so if I download this, I can put it into like PowerPoint.
It can be both. It depends what you react with.
The benzene can be both electrophile or nucleophile.
Yep.
Okay.
Once we've done, once we get rid of the PDF, but it was gonna be a substitute.
Also, we cannot just see by itself, we have to see what it's.
That
Okay.
will drive it pretty well.
So I have a PostScript or PDF file.
If that
wants
wants
to download
MLG,
these, that's where I use the
like
SCP.
methoxy, O,
Or you can help.
OCH3 or
OH,
alcohol.
okay, so it's OH, it's electron.
SCP is more reliable. It will work.
Taylor, are you having a problem?
It
Just
stabilizes by
trying to use the side thing to
resonance.
get my files. It's locked or frozen for some reason.
That's annoying.
But you need to download and bring it up. See what.
So if I do SCP,
Yeah.
where does that download to?
Okay,
So I'm trying to remember.
It downloads to
So
the,
things like carbonyl.
Okay.
the home directory of wherever you set it up, which I don't know where your home directory is.
That's-
Dimitri,
Yes.
why do you
Of half.
save it as a PostScript instead of just a PNG?
Which causes the benzene.
Because I do not like PNG.
Okay.
Why?
Compare
So
your
it's
R
the
group.
carbonyl,
Because-
these guys are the one that cause it, okay.
Yeah. So that
It's the
you
substitution.
get big negative charges here, which pulls all negative.
If you order printing at Print Center, they will request converting of your files to PDF anyway.
Okay.
So what do? We refresh, refresh folder.
Yeah, tangent
So we can go to the directory with where we were working. Continue. And we see here the symbol of this same like Mercedes or pacifist triangle symbol. So you can click on it and it will come here to the screen.
Mine's been freezing. I don't know if yours is.
Yeah, mine's like it doesn't do anything either.
So you can follow idea of Levi and create PNG file immediately, or you can type
In
Print screen.
New plot, you can save
Yes.
it as a PNG.
yes, or you can make print screen of this file, or just copy this file and insert it into your PowerPoint or Word file that you will use for your homeworks, publications, theses, posters, presentations, web pages.
Project next to the state's market.
So you won't mind.
All the,
Under the shadow of this.
all these guys plotted for all these compounds.
That's.
I don't have
Thank you. I wrote a script.
So here is this image inserted into the PowerPoint. I don't know. It is a PowerPoint of some psychology class. But but here, so here is density of states computed for titanium hydroxide. We see this gap from of about 13 point something electron volts, and if we use another method, or if forget about other method, if you make a model of predominantly colorful molecule, then this gap will be much smaller, in the range of 2-3 electron volts, corresponding that matching between visible range and energy offset between HOMO and LUMO. Whew. Any questions about section number 2 of our meeting? Please make sure that you can download this image to your laptop, and you can insert it into PowerPoint or Microsoft Word. Raise your hand, attract my attention if we need to have a close look on it.
So from which file did you get load?
Like that.
So if you open it, reconnect. Right, reconnect.
Yeah, right.
But I don't know how to do it through internal.
No, it's and remember what Seth was telling you. If you do not do anything, type QP.
It's
Oh shit.
garbage. It's fine.
Be careful with wording because we are on the road now.
Kind of tempted to.
So if you
Do
are
all this with my boyfriend.
I was able to get in this time, just clicking through, so maybe to my folder.
You just exit right after? Or just
Yeah, it kicked me out. I went back in and then tried again, and it went quite a bit quicker. So
I guess that's troubleshooting 101.
well, I think I've tried it twice now, but third time's a charm. So
So does that mean every 3 times it will work?
I wish I'd be a great scientist.
Model
Everything you can try work.
No, I'm talking about this
Okay,
specific thing.
no,
That's a
everything
terrible
is working.
success rate.
This is just quick mouse operated
all the time.
mode.
Not on a computer.
If it doesn't work,
Well, I
you
don't do
do
much
this
on the
What I
computer.
like to do is figure out
CP.
based on.
Yeah. Unless it's like Gaussian, and then sometimes it's like, what did I do wrong? Oh, I must have had a syntax error. Nope, that wasn't it.
Without doing computation.
Yeah,
But
What would be
but I want to use that to figure out what my angles are. No, that it's measure versus distance.
DOS underscore
But
G
there wasn't-
09.
There are no plots where they show angle versus
Empty space.
frequencies or changing frequencies or anything like that. So that kind of sucks.
Just use
So
That'd be
after
cool.
this, you have given it empty space, then dot.
But there may not be a trend. But that's okay.
Well, you need to find this file in your local computer.
So it's downloaded automatically by that file.
But this command, yes.
It's in the downloads maybe.
No, this PC. I think it would be. Let me do something really quick. This will go.
It's a relative.
Because the war split after this.
Okay. Name of the cluster.
They get distances too.
No. And then I can just start the anything that ends with PDF to here.
Making sense now?
So much more sense, thank you.
Are you an Angry Bird fan?
I do like the game, but this is a mud run.
Oh, it definitely looks like the piggies.
You're right. I've never.
And I actually put it up a lot.
Even though I don't see why they use two capital D's for the nose.
The dirty dash.
Okay.
Oh, okay.
Maybe it's not a bad.
A lot of it is
Something.
Slater type.
I don't think I would want to wear a shirt that makes runners seem like they turn into pigs.
Well, you're in a mud run around. So.
So what? I feel like this might be part of the thingamabobbers.
What was? So we got a couple different things. I took the
Oh,
those two different ones.
he's two.
You don't have an hour left.
Okay. I mean, it's really similar. It's just
There's just one more. It's more broad. I think one is a Lorentzian and one is a Gaussian. I think the blue is the Lorentzian and the red is Gaussian.
The third one, I don't know what that is. It's just,
That's another energy. So
just another axis. So this is in. This is another x-axis. That's what it is.
yes. So the difference between the first and the fourth is the first one
Oh, I
is the
see.
straight
So next
compilation
to-
energy. The fourth one is
You see,
kind of so it's kind of like getting the Fermi energy.
you go to
If you plot it,
this directory.
zero is the half the band gap. So I always plot half the band gap. So I do 4 and 2, just so
Yeah,
then
that's what this is. Okay.
just so then it's there, because if you compare a lot of different spectra, it's more important about what happens.
The relative width of the gap. And
Yeah.
then shift.
Because this is all relative anyway, so if you excite an electron, it doesn't matter if it goes from -50 to -40 or -10 to 0.
Have you seen the devices where they always have band gaps, like a solar cell or something like that? They'll have something like this. They say electron cube.
Yeah.
No, so they wouldn't be using this
No.
one. They'd be using.
They would use it
one
relative.
That's 2, 1 and 3.
1 and 2, yeah.
1 and 2.
Yeah. But typically,
if that's not
The only
the
stuff
issue,
that
you're
I
not doing a
was
solar
doing
cell
around
thing.
this,
Yeah, if
Conversion
you,
from postcode
like,
into
I
PDF.
typically look at if it's trap states, what if, like, what happens to the homo lumo, what happens to the band gap,
This
or
is the
technically, I don't think you can call it a nano. Like, quantum dot have band gap, because it's not actually bands. Because it's not.
This one has been
But,
downloaded
Because there's.
We know how
Some people are
fast
thinking about that.
the DA.
and
I
it is
was at, I
downloaded
gave a presentation,
into
someone's like, you can't
this
use
PC.
band gap, but there's no bands.
No,
You have
so
to
those
use
homeowners.
gap.
So,
So you should tell everyone in there? Literature.
Yeah, it's.
Like he
Yeah,
was
I'm
a,
gonna like
you know,
go through it.
he was a organic, inorganic polymer chemist.
He got tired of all the other,
But,
yeah,
yeah, so
companies
like,
coming in.
if you were worried about this, then that would be,
I'm copying.
but.
Copying what he's doing?
That, do it in
Were you
like
able
this
to
way,
bring this image to yours?
probably would not have, write it as a DOS. You would
Yes.
write it as,
You were not,
energy level.
So I just wrote it
Because
down the
it's-
steps.
Comparing
This is,
this, like,
this
you
one
have
from the networks.
3 dots on one, and they are
I'm going to.
all over the place, and really.
Oh, so you're saying.
Yeah, I know.
Yeah,
They just
usually
have,
it's
yeah.
It's
very.
So we can
So it's kind
if the connection is quick enough.
Yeah, if you're more, you actually care about.
So like, all of mine that I've plotted,
Actually, I'm that folder.
Do you plot it in, do you actually use the plot that it generates within here, or do you put it into another reference?
Put a different folder in my
I
own computer.
wrote a different one, right, what you were saying, because I don't always, I never really plot with this, but like, that's not the one I want.
We ran across it, right? You can run a state calculations.
Well, yeah, you can see how the pH intensity changes, the orbitals change.
That one is.
Well, this is
I'm
what
missing
Yeah,
now.
what is the
So is it-
So like, this is the plot I made.
What's the,
You know,
oh, so you do use.
yeah, but mine, I did.
No,
Intensity
it is okay.
of this thing, this states, so show,
I'm
So-
going to
here's your,
This
it'll show the same element, but one of the
range of
Here's the one electron.
But if you look at,
Like this stuff?
if you look at this command here, I say set terminal PNG. I don't know what his says, but his doesn't say that, and
There
then
isn't much electronic.
I just say set output whatever
There isn't much
plot
electronic.
forward verse 2, so I say plot this.
No.
But I save it as a PNG, and then I don't have
Well,
a
I
computer.
got,
PS2 PDF.
if you go wrong.
What if you wanted to change dimensions and stuff like that?
You would do it in,
If it doesn't-
so like if I wanted to say my x-axis from
You don't go
0
straight
to,
from ground.
since I do this, I could just say -6 to 6, and then I could also do like a line range.
No, I have already.
But
You can do that all with one.
yeah, it's all with
Oh,
it,
no, no, Sigma.
and it would make the exact same plot every time,
Can we go to Sigma?
Okay,
without
and
having.
then,
So you,
like,
so yeah, there might be.
so I had to spend a
It's-
couple weeks here recently, working with an origin, and I had to change like the thickness of this, can you do the border thickness of
Of the border?
making it look pretty?
What is it?
Just this.
Out of seconds.
I'm guessing you can somehow.
Yes,
So that
you can modify everything.
fluorescences.
Yeah.
Microsecond.
I prefer to use a different program, but it's much more difficult. So I recently found Python, which is a programming language, which is
Just one
super
simple
easy to learn, but you can import a lot of stuff. There's a ton of things that you can do. So in there's one library that's matplot.lib.
So.
Yeah, move plot stuff, and you can say, okay, I want this dimension. I want the lines to be this, I want the y-axis to be this, blah, 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 blah. So like, I wrote a script to plot certain things.
Yeah, so.
So like, this,
Because.
it takes
That experience.
files and it
Time there.
can plot this automatically, and I think it's a lot better. But I could say I want to have it 2 inches by 5 inches.
That's what's
Well,
crazy.
SIGWIN is more reliable.
Yeah, I just found
If the graphical doesn't work, then you go to SIGWIN.
And like, if I run this command,
Everyone is happy? Everyone was able to make this density of state plot?
Yes.
Good. What do we have left? We have about 20 minutes before psychologist will start kicking us out. And we want to get maximal pleasure from these 20 minutes. So the so little write-ups here show the similar procedures for generating orbitals, which are the best part of the course if you forget about movies. So when we were in the class, we agreed that Hardy-Fock method has molecular orbitals as a bridge between atomic orbitals and overall wave function. These orbitals are stored as expansion coefficients in front of atomic orbitals, but if you multiply the space distributed atomic orbitals by expansion coefficients and bring them together, we can plot molecular orbitals as isosurfaces distributed in space, right? And this may help us to launch our chemical intuition and learn something about molecules, like if there is a distribution of the wave function, not wave function, molecular orbital across the molecule, then it probably has chances to be conductive, or it may contribute to, if the HOMO and LUMO distributed in the different regions, it will be a charge transfer, or it will be no absorption if they do not have overlap. So some conclusions can be made by looking onto the orbitals. How do we proceed? So, okay. Phew. What does it mean? That we are disconnected?
Or someone is calling.
So right now we will need the graphical connection.
I think there's some at in there.
Yep.
At HPC.
Yes. I'm not as fresh as I should. So when we were launching the job, when we were preparing the input file for Gaussian job, there was automatically added line CHK equals something. You didn't need to care about it, it's added when you launch, but if you want you can modify it and contribute it intentionally. So upon the completion of the job, you do have so-called CHK file, which takes the largest number of kilobytes or megabytes or gigabytes or terabytes. depending on the size of the model. So it stores everything what is possible to store about this model. Sometimes a lot of garbage that no one needs, but right now we find that it contains important or interesting information about orbitals. This do not do more of this file. You'll see like unreadable garbage on the screen. It is stored in the binary form. So you will see like percent question percent without not readable. But it can be converted into better format, less compressed. You can, so to say, unzip it by typing form check and then the name of the file. So you type this form check, FORMCHK, and then name of this check file, and you do see that there appears additional file with extension FCHK. So last meeting in the class and few next meetings in the class, we will talk about expansion coefficients in front of atomic orbitals. Those are condensed data, and we may want to convert these expansion coefficients into shapes in space. So this operation is a little expensive, and therefore it was not made once for each orbital. The information is stored only in the form of expansion coefficients. But if we want to create spatially resolved images, we need to use the part of the Gaussian code that is stored as the separate executable and is named as a CubeGen. So you can launch it and start answering silly questions, or I have created a little prompt for myself in case my memory doesn't serve well. So you type CubeGen, you type letter O that stands for orbital, then you type the number of orbital, and then you type the name of the file with your expansion coefficients, and then you type the name of the output file. Once again. This one. No. Okay. Yes. So again, so the name of the command, then O for orbitals, then MO and number of orbitals. So you will need the number of orbitals that you are going to plot. And we are going to scroll through list of orbitals and count which of them we need. Then you give the name of your Gaussian output .fchk, so it is a file that does contain expansion coefficients, and then you design any name for any name according to your creativity, the file that will contain the information about space distribution of your orbital in as a grid points in space. Grid points in space. So I am going to do more E underscore file, and here I'm scrolling until I see where number 2 converts into number 0. Once again. So more of the E underscore list of files, and then you see orbital number 1, orbital number 2, orbital number 3, and I'm looking on the last row, last column. It has 2, 2, 2, 2, 2, and then 0, 0, 0. So most interesting are so-called frontier orbitals, HOMO and LUMO. Well, we can plot any orbitals, but most important physical meanings are for the HOMO and LUMO. And then I do identify that highest occupied molecular orbital is number 24. By the way, if you redo the calculation with different basis set, you can get different number. It is not once and forever, because you may, some of the basis set neglect core electrons and some include. Okay? So I would like to practice exactly this line. So Q gen orbital MO for molecular orbital number 24, which will be HOMO. Then I need to correct the name of the check file. So here it was Hartrefog 102DZ FCHK. And then I give the output file as MO24 just because it's molecular orbital number 24. But I can write my favorite orbital and my point of joy or something like this. It doesn't matter.
Just said HOMO.
Right. Pictures at home. And click enter. So it doesn't respond immediately because it takes a couple of seconds. And after you complete this line, you may inspect LS minus OT. And you see that there is a new file generated that is exactly named as mo24.cube. There are two. Oh, please attract my attention if you didn't get this file. Means everyone has it, right?
I'll take TOP.
So,
Did you get it?
I got it this time. It's amazing.
I didn't get it.
No.
But yeah.
I don't know. Next time.
Oh, I'm sure I'll have good luck.
And too. I'd explain it to you, but I feel like that would be very useful for you. Be like
Because I would have done command to get HOMO.
I would have told you
To open the file.
No, I probably will. Let me see, what did I do? That's what I was stood here and Stanley should be all that trying to figure out what I had done.
No, but if
You
you.
already have.
What file was that?
What did I just open?
The one that you opened to find 2.
So I am trying the.
His file.
The one that.
Yeah, that's how you get.
Uh,
I don't know why all my form checks are the same, but all of it. Or
Is your original title has that?
I know, but I
I
changed it.
have all the files that he has.
And it doesn't
But
matter. They all.
You could do like
What is
Ah.
the name of the thing?
money sign 4
That's okay.
greater than 1.
So the file is fig_hf.
That, whatever the file
Check.
that he looked at with the occupation, right?
Underscore
Then just pipe that into a tail command,
check.
-1, and then it would give you the last line with occupation greater than 1, which is
You just have one check.
So you're just trying to find where
yeah, without actually opening it and
it's going to. I did that and then
you formatted your checkpoint file.
Okay, so there are two ways to plot it. There are more than multiple ways. As soon as you have this cube file, you can also download it to your computer and plot it with Avogadro, with a recent version of JMOL. But suppose we have only terminal connection. There is a Gauss view that can plot molecular orbitals, and there is a even more ancient piece of software named Molden. That is, the simplest things are more reliable, although they're not as fancy in how they look like. So let's start with Gauss view, as it is something we worked with before. So here is Gauss view window, and I'm going to File, Open. Here I'm selecting, instead of Gaussian output files, I'm selecting cube files. And I do see this MO24 cube. So why while cube? What does it? Everything has little meaning, some meaning. So cube, because it is grid points in space. Grid points in space, and they are typically square. So it's area of space that looks like a little cube that contains the molecule. So clicking open. Right now you will see only the molecule. But we can go into menu, results, and select surfaces, contours. Then you will get the menu that will have 3 panels: cubes available, surface available, contours available. And in the surface action, you can click new surface. Over. That's it. Then you catch the screen and bring it to the PowerPoint. So let's print screen and bring it to.
Oh my god.
I don't want to do any more cube guns.
Yeah.
Bring it to the PowerPoint. So
So how does it actually? How does it see that picture? That
how to catch screen?
Yeah.
There is a print screen button on your keyboard.
Not all keyboards have it.
No, mine doesn't.
Oh,
You have to do the
I can-
commands.
Okay, teach others. How do you
Do you have a function key?
Windows 8 has a little clippers thing.
Actually, you do a print screen button.
Mac has
So it should be
Command
super-
Shift forward, and then you can go and highlight.
You can also use the snipping tool.
That's what I was just saying.
It's great for old PowerPoints or old PDFs.
Yeah.
So documents, or pictures even.
You need to find plans this weekend.
Or what you can do.
Yeah, but I can have
Open pane.
Nice.
Or I can just
Yeah, you can go biking there. Have you ever been biking?
take the snapshot of it.
So
Nice
so
trail, mountain bikes.
for mine, it
Mountain bike.
automatically saves
I
it as
knew you had a road bike.
an image file.
So you
Sometimes
would've
it doesn't,
wanted
it
to
just copies it to the clipboard.
Oh,
So
my butt would
if you
get
open
so
up
we put-
Paint or
The first time
Word,
I was
just
just on it a
paste.
times first.
Oh.
I didn't have any.
It'll paste the screen.
Oh.
It was moving in circles.
So
oh,
Did it work?
And road
Yeah, yeah,
bikes, you
I
don't
can-
wanna
I can-
Okay, everyone got how to get these orbitals? What else can we do?
make it
contour maps.
Hmm? Let's scroll through available.
You make it opaque.
Oh, you mean you can change the visual presentation?
Yes.
That would be good because people are red green colorblind.
Well, there are different things that you can.
I didn't even realize that.
Seth Rasmussen is red green color.
So for your second year seminar, don't do that.
In my experience,
I'm not plotting any.
the most of the spectroscopists are colorblind.
Which is weird because
If a person is colorblind, there is a suspect that he or she is a spectroscopist.
which is weird because like for Dr. Soon I use JMOL and she's asked me to make it red green.
There is a safe way to make it color code and at the same time make it like dashes
Yeah.
or contour plots with lines. Let's see here. Here is the ISO value for a new surface.
Make that tiny.
Do you see this number? So it shows, since the distribution of molecular orbital takes all space and we are plotting only surface, so we are plotting only those points where the value of the absolute value of this wave function takes specific value. So if we take very small number, we will protrude very far in space. If you
I thought I saw someone out. I saw someone walk by. I don't know if it's for us.
I just want to leave. No.
Oh, see, someone just walked by.
It is a well-respected janitor who is probably not looking to join the class. So, Modern is an ancient software that was designed much earlier than Gauss View. So you'll see something like this little window, and it has the density mode, probably 5th line from the top. You click it, and then it will have the read right cube near the skull. Click it here, read, Gaussian, and you type the name of the orbital. Name of the orbital, M, O. Probably it responds to my cube. On clicking something. O cube, enter.
What is
So it is for colorblind people. It shows contour lines, which probably not as visually appealing nowadays, but like 15 years ago it would be okay. So meeting is dismissed. Thank you for staying so long, and looking forward to see you tomorrow in class.